Okay. We have simplify the square root of 12 x squared. And one thing that I do is, you see how this x squared is hanging out, is I like to draw my radical and then a little notch so that I know where it ends. And I don't get it mixed up if there are any other things in the equation. So I want to simplify this, and we're going to use the product property of radicals in order to simplify it. So the first thing that I'm going to do is pull it apart. I know that the square root of 12 x squared is the same as the square root of 12 times x squared. Now let's look at this. The x squared is a perfect square, so we can pull that out. Now 12 is not a perfect square, but 12 is made up of other perfect squares. 12 is 4 times 3. So we can take the 12 and we can actually divide that into 4 and 3. So in reality, what I'm going to do is I'm going to say the square root of 4 times the square root of 3. Okay. At this point, what you want to do is we have the square root of 4 times the square root of 3 times x squared. And then what you want to do is the square root of 4 is 2. The square root of 3 remains the square root of 3, but x squared, the square root of that, becomes x. Okay. Now we need to simplify this and put it in the way that the normal order that we would see them in. And this would be, we put our numbers that do not have radicals in front. So the 2x goes in front, and then we leave radical 3. So this would be in the simplest form that we have for the problem. Now, example 2 has two different parts, A and B. So let's look at example 2. And then A. A says radical 8 times radical 2, and it's supposed to be equal to something. So when we multiply a radical times a radical, this is the same. We can use the product property of radicals the other direction. So this means I can say 8 times 2, and I can get the square root of 16, which we all know the square root of 16 is just going to be 4. So that's A. Now for B, we have the square root of 5x cubed y times 2 radical x. Okay, and they're saying to simplify it. When I simplify this problem, to multiply these types of problems, is anything outside gets multiplied by what's outside, and then what's inside gets multiplied by what's inside. So there is a 1 here. So what's going to happen is 1 times 2 is 2. And then I multiply what's inside by what's inside. So x cubed becomes the 5. There's nothing there, so that's 5 times 1 is 5. X cubed times an x to the first is x to the fourth. And then I have a y, because there's no other y over here, so it stays. Now we want to keep simplifying. Let's look at this. This 5 is not a perfect square. So 5 is going to stay inside, and it's not, doesn't have any factors that are perfect squares. Now x to the fourth is x squared times x squared. So if we have the square root of x squared times x squared, the square root of x is x, and the square root of x squared is x. So this actually becomes an x squared, because this would be x to the fourth. So the square root of x to the fourth is x squared. So I can actually pull that out. 2 x squared, okay, just like I had here. And then what's left, I took the radical of this, is a 5 and a y. Okay, and that is the correct answer for B. Next problem is the quotient. Actually, we're going to talk about quotients, which is dividing radicals. Now, when you divide radicals, there's some rules with dividing radicals. and I'm sure you had them last year, but we'll go over them again, is that whenever you have the square root of a divided by b, and it's in a radical, you can break up the radical. This is the same as the square root of a over the square root of b. Okay, and again, a has got to be greater than or equal to 0, and b has to be greater than or equal to 0. Now let's do the example. This is on page 151 in the middle, and we have the square root of 4 divided by 9. And this can be divided. We can just take the square root of 4 divided by the square root of 9. And the square root of 4 is 2. The square root of 9 is 3. And that would be our correct answer for that problem. Now, let's apply that in some other examples. Example 3, A. The first one says the square root of 11 over 49. Now, if you remember, 11 is prime, so it's just 11 times 1, so there are no perfect squares for that. But the square root of 49 is 7. So this is the square root of 11 divided by the square root of 49. I can divide those up, and so I get the square root of 11 over 7. Okay? And that would be your final answer. Now, some of you may be going, hey, what about that second one about no fractions are in the radicand? Well, in this case, the radicand is in the numerator. So what they mean by no fractions in the radicand is you can't have a radical that has a fraction inside of it. And the 11 here is a whole number. So it is not a fraction inside of it. And the 7 is separate. So this is the simplest form. This is the correct simplified form. Now B, okay, B has the problem, this is example 3B, and it is the square root of t squared over 36. Okay, now the square root of t squared is going to be, we can write the square root of t divided up over the square root of 36. And here what we want to do is take the radical of each one. So the square root of t squared is t, the square root of 36 is 6. And that's our final answer. That is the simplified form for that problem. Okay. Now it is time for you guys to do some math too. I want you guys to try. Page 152, I want you to do numbers 1, 2, and 3 for those problems. 1 is the square root of 16, x to the 4th. 2 is 4 radical mn times 5 radical 5 m. And 3 is the square root of 15 over 25. So simplify those expressions and see what you get.